Solid edge simulation allows everyday engineers to test design ideas as they work. In ST4, it's now even easier to idealize or optimize your designs with mesh refinements, more mid-surface, and assembly design capabilities for improved machine design analysis, especially those with sheet metal components. Solid Edge's mid-surface capability allows fast-solving 2D shell elements to be used which speed up an analysis for sheet metal components. To simplify the mid-surface creation, the surfaces can be extracted at the assembly level and used in conjunction with regular solids in other parts of the model. Furthermore, mid-surfaces are associative and automatically kept up to date. Solid edge simulation can be used to analyze stress, strain, force, displacement, and more. In this example, we analyze the caster bracket to see how far it will deflect under a heavy load. You can analyze assemblies or parts in Solid Edge. Here, we'll just focus on the key assembly components to give realistic results more quickly. A key aspect in Solid Edge ST4 is the ability to use a combination of mid-surfaces and solid models in the same study. Meshes created with both 2D shell elements and solid elements give results much faster and more complex models can be analyzed. The study here will be a hybrid of both element types and will show how Solid Edge models the interface between the different element types. To help you create more real-world simulations, edge-to-surface gluing is now supported. This allows edges of shell model components to be connected directly to faces of other shell or solid components, so you don't need to match element sizes and node positions. Part-to-part contact is now much easier to set up with quick face-to-face connections, and new graphic symbols for source and target faces make them easier to recognize. Solid Edge simulation uses our industry-standard NX Nastran solver to get fast and accurate results. In ST4, you now have more control over the quality of mesh for optimizing speed and accuracy around complex geometry. For example, you can control the minimum elements on an edge, ensuring small edges are represented by an adequate number of elements in the final mesh. To optimize complex models, a maximum angle tolerance limits the angle between facets on curved surfaces, while curvature-based options automatically increase mesh refinement on tightly curved faces to help ensure higher accuracy without sacrificing overall solve performance. Also, quad edge layers forces placement of quadrilateral elements around stress razors such as holes. This new feature is yet another way Solid Edge simulation helps optimize solve speed and accuracy. Results are now easier to interpret. For example, the color bar has improved numerical formatting, so the best format for each number is automatically chosen to make it much easier to understand. In this example, the results show that the wheel bracket will deflect too much, so some edits to strengthen the part are needed. The unique integrated design environment in Solid Edge lets you modify synchronous features fast, while ordered features such as mid-surface are kept up to date. Using synchronous technology, we'll make the sides of the caster bracket parallel and fix the leading radius size with the drag of a mouse. For thickening the sheet metal bracket, you can easily change the thickness value from the toolbar. This handy override makes it easier to try out different what-if scenarios. Synchronous technology lets you make precise changes by using 3D driving dimensions, key point snapping, or by entering offset values as shown here. Because the mid-surfaces are ordered features, they're kept up to date automatically during any synchronous edit. After the edit, a quick resolving displays the new results. The combination of changing the material thickness and shortening the limbs on the caster bracket gives an acceptable design. The deflection seen under maximum load is now within the design parameters. The results can be saved as an AVI to animate your results, and it's possible to generate reports in common formats such as HTML or Microsoft Word. With these new mid-surface capabilities and meshing options, design analysis is optimized for fast, accurate results, even with complex designs, so you can try out more design alternatives while reducing physical prototypes.